The chemistry behind Captain America's growth. In the movie and comic, Captain America, a man named Steve Rogers, is turned into an American super soldier. With the help of a special serum and exposure to Vita rays, Steve's body is transformed from a 90-pound, 5-foot frame into 6 feet and 250 pounds of pure muscle. In addition to physical changes, Steve also turned from a man of considerably poor health into a man at peak condition and strength. On the right, we see Steve Rogers before the serum injection, and on the left, we see him after, as depicted in the movie by Marvel Captain America. This is a clip from Marvel's Captain America, the First Avenger. It's when he's getting injected the serum and being exposed to the Vita ray process.
Mr. Stark? Son of a bitch did it. Yeah. You did.
How'd you feel?
As we see in that film, it was obviously very stressful on his body, and they almost wanted to shut it down for fear that he wouldn't make it. But in the film, Steve Rogers does successfully come out. Now we wonder, is that even possible in real life? Clearly we know that Captain America is a fictional tale, but we can't help but wonder if something like Steve Rogers' serum growth could happen in real life. Unfortunately, we have discovered that the superhuman growth depicted in the film and comics is not possible. The reasons it's not possible is because, obviously, the procedure is very stressful on the body, and it appears impossible for the real human body to endure such a process. Obviously, with the help of movies, Steve Rogers was able to go through and the film, and of course in comics, but in real life we don't think that a human body could endure such a process. In addition to physical stress, the superhuman growth seen in Captain America is impossible because the super soldier serum and Vita ray process do not exist. But there is a slight shred of hope. Although there is no super soldier system or Vita ray process, there are advances in modern science and medicine that have made certain Captain America-like qualities a possibility. Today, the genes that involve muscle growth and blood oxygen carrying capacity have been identified. The process to turn these genes on and off has also been discovered. Thus, you ultimately could go through epigenetics to turn on specific genes to increase strength and agility. So if you wanted Captain America strength, or maybe Captain America agility, we could potentially find a way to make that happen. We got most of our research from Stanford biologist Sebastian Olivardo. He explains the science behind Captain America in this clip.
So how did scrawny Steve Rogers turn into superhuman Captain America? A lot of people don't know, but what it comes down to is that super soldier serum and Vita ray process. What's inside the super soldier serum? I don't know. The scientists in Marvel's universe don't know, but it's a lot of fun to speculate what could have been inside of that. What we do know is we know a lot of the genes that are involved with, let's say, peak physical human shape. This means we understand the genes that increase muscle mass. We know about the genes that increase oxygen carrying load within your blood. We know a lot of this information. And we actually have a lot of tools to specifically manipulate those individual genes in order to turn them on and turn them off. We actually call that whole term epigenetic modification. So basically a light switch that you can put onto a specific gene. And more importantly, we have a lot of tools to take advantage of that. We have a lot of genome editing tools, things like zinc finger nucleases, Cas9 CRISPR systems. The fact is that these tools are there, we can use them, and we can specifically target individual genes within your genome epigenetically modify them, turn on a gene, turn it off, and hope that those specific genes, in this case, can basically seek out specific genes that are, let's say, related to making your muscle really, really large, or making you very strategically minded, or making you incredibly fast, increasing your stamina. But that isn't enough, right? So I don't know if you guys remember in the movie, there was this use of Vita rays, and it's important in the comic books as well. So they inject him, they wait, and then they put him inside the Vita chamber where they just zap him with these lights. These lights of mysterious origin and powers. But what's really interesting about that is that it ties into a lot of really interesting approaches to pharmacotherapy. There are a lot of photosensitive carriers of drugs that exist in development that are being researched right now. One example are dendrimers, for example, or if you shoot UV light at them, they actually break up. So anything they're carrying gets released into the tissue that they are currently embedded in. So if you imagine Stephen Rogers with one of these nanocarriers carrying everything he needs, let's say these genome editing tools, to turn on the right genes for increased muscle mass. You put it in him, you put it in your muscle, and then you zap him with these Vita rays, or UV light, or anything like that. You can specifically activate these molecules to release their load and to have a very specific function in a very specific tissue. Which isn't to say at all any of you should try this at home. In fact, it's probably a very bad idea, and the extent to which we've explored these directions have been mostly in lab mice and things like that. Either way, it's fun to speculate these things, and that's why we have comic books, movies, and science fiction.
For more, please visit us at stanford.edu.
So as you see from this researcher that obviously it is not possible for a typical human to become Captain America. Although there have been some discoveries, it's still not probably very probable in real life. However, nevertheless, it's still entertaining. Thank you for watching our presentation. We hope you enjoyed it.